Chapter 3, Section 5. We are going to start on page 155, working with equivalent fractions. If you look at 1a, we start out with 5 6, and we're taking it to 15/18. What do I have to multiply 5 by to get 15? 3. Whatever you do to the bottom, you do to the top. Whatever you do to the top, you do to the bottom. 6 times 3 is 18. That is 1. It's important that you understand that. That is 1. That's why we can change fractions. 3/4 times what is 15/20. 3 times 5 is 15. Whatever I do to the bottom, I do to the top, and same vice versa. 4 times 5 is 20. 5/5. 5/8 times something is 15. 5 times what is 15? 3. I put 3 on the top. I've got to put 3 on the bottom. 8 times 3 is 24. 9/27. Notice the 27 doesn't change. 1 keeps it the same. If I put 1 on the bottom, I've got to put 1 on the top. 9/27 is 9/27. This is called the multiplicative identity property, or I will say a lot of times in class I'll say the identity property. Whenever you're multiplying a times 1, it's going to equal a. Any number times 1 is that number. So if you look at a, 1/4 goes to 16. 4 times 4 is 16, so I got to multiply the 1 by 4. So I have 4/16. 2/3. Let me write it a little bit bigger. What am I multiplying 3 by? 2. So I can multiply the 2 by 2. 2 times 2 is 4. 2/3 is 4/6. 7/16. I went to 30 I multiplied that times 2. If I multiply the bottom times 2, I multiply the top times 2. 7 times 2 is 14. I can go either way. 12ths, looking for that. 3/4. Working right to left. What did I multiply the 4 by? 3. So I multiply this 3 by 3, and I get 9. 3/4 is 9/12. Number 4. They want us to write the first 10 equivalent fractions. Let's just do a few. 3/5. The first one would be 6/10. 3 times 2 is 6. 3 times 3 is 9. 5 times 3 is 15. For the fourth one, 3 times 4 is 12. 5 times 4 is 20. You're going to start seeing a pattern on the top and the bottom. For the fifth fraction, 3 times 5 is 15. 5 times 5 is 25. 6, 9, 12, 15. This one's going to be 18, 30, 21, 35. Whatever you do to the top, you got to do to the bottom. The rest of the chapter, we're going to be dealing with reducing fractions. This should be a good review. Look at problem number 6 on page 158. The question asks, circle the fractions that are simplified completely. How do you know? 9/13. 13 is prime, 9 is not. The only factors that 9 have are 1, 3, and 9. This one is simplified. You can't make it any smaller. 10/32. Whenever both numerator and denominator is even, you know that they can be divided by 2, so you know it's not reduced. 9/12. Think of the factors of 9, 1, 3, and 9. Factors of 12 are 1, 6, 1 and 12, 2 and 6, 3 and 4. This one is not reduced because I can divide them both by 3. 12, 144s, once again, they're even. It's not reduced. 7/12. 7 is prime, so all you have to do is check to see if 12 can be divided by 7. It cannot. 33/55. Can that be divided by any number? Yes, I can divide it by both of them by 11. It actually reduces to 3/5. A little practice for reducing fractions on the bottom. Write each fraction in its simplest form. 6/9, this is where you got to know your multiplication facts. I'm going to divide both of them by 3. I'll try and write that again. So that would give me 2/3. 8/24. Always check, just a shortcut, see if the numerator can go into the denominator. If it can, it'll save yourself some time. I can divide both of these by 8, and that reduces to 1/3. If you do not recognize that, you should recognize they're both even. You can divide them out by 2. Eventually, you'll get to the same answer. Same thing with 18/36. Okay, so they're both even. I'm going to divide it by 2. That gives me 9/18. I know they can be divided by 3, so that gives me 3/6. I can divide them both by 3. Gives me 1/2. Whenever you can double the numerator and get the denominator, that fraction is a half. Look over here at F, 14/42. I know I can divide them by 2. Can you count by 14s in your head? You will get to 42. You can divide both of these by 14, and you're going to end up at 1/3. If you don't recognize that, divide by 2. It'll work. All right, this is a different way. I just want to show you how to use prime factorization to reduce fractions and also GCF. It's just a different way to do it. Okay, your favorite, 15 and 20s. So I'm going to do the prime factorization. 3 times 5, that's not so bad. So I'm going to write 3 times 5 over here. For 20, it's 10 and 2, 5 and 2, so it's 2 times 2 times 5. Now with this method, you only take out numbers that are on both the top and the bottom. So the only numbers that are the same are 5. So if you divide 15/20 by 5, both sides, you will get 3/4. And that reduces 15/20 to its lowest terms. That's using prime factorization to reduce a fraction. Another way to do it is to use GCF. I'm going to show you a different way to do GCF. Write 45 and 56 in a chart. When you're using this chart, you have to think of common factors that can go into both numbers. Mr. O'Leary picked 2 numbers that they have no common factors. That one's reduced. Sorry about that. All right, look at A. Let's try it again. 24 and 28. Put it in a chart. It looks like this. The terrible A. I can divide, I'm going to use 2. So I put 2 out to the side. 24 divided by 2 is 12. 28 divided by 2 is 14. They are still even. I can keep going. So I'm going to divide both of them by 2. 12 divided by 2 is 6. 14 divided by 2 is 7. I cannot reduce or divide 6 and 7 by the same factor. You're done. So then you draw a G around the left-hand side. Multiply all the numbers inside the G. That is not your bill. 2 times 2 is 4. That's the greatest common factor for 24 and 28. Back to the original fraction now. 24 over 28. If I divide 24, that gives me 6 sevenths. That reduces to 6 sevenths. It's just a different way to reduce a fraction using prime factorization and greatest common factor. Sometimes it's a lot more work to do it that way, but there's always a different way to do a math problem. Okay, so that's section 3.5. Make sure you get the practice sheet. Good job.